Hello and a very warm welcome. My name is Nawied Jabarkhyl and it's a pleasure to be the moderator for this webinar on harnessing AI for sustainable energy future, hosted by the Al-Attiyah Foundation in partnership with the London Stock Exchange Group Data and Analytics. Again, welcome from wherever you are. Before we get going, I'd like to go over a few housekeeping rules for the discussion. First of all, for the best viewing experience, please read the instructions above the media player. If you do face any technical issues during the webinar, please try refreshing the page or reaching out to the team via issuer services at lseg.com. This is an interactive session, so if you have any questions for the speaker, you can click on Ask a Question. Please note, in the interest of time, though, we may be unable to address all of the questions, but they will be recorded. During the session, you will be participating in polling questions as well. As it's interactive, we'd like your thoughts on the polling questions we pose to the meeting. And the recording of the session will be available using the same events link once we're done. So AI, something that everyone's talking about, it's rapidly reshaping the global energy sector, artificial intelligence revolutionizing every stage of the value chain from exploration and production to distribution and consumption. As the industry faces mounting pressure to cut costs, to improve efficiency and accelerate the transition to cleaner energy, AI is emerging as a critical tool to drive innovation and resilience. The energy sector is already investing heavily and making strides in leveraging AI's potential. Recent estimates indicate that AI serves more than 50 different uses in the energy system, with the market for AI-driven solutions in the sector projected to reach up to $13 billion. It's all across the value chain as well. From the upstream sector, AI is transforming resource exploration and extraction by pinpointing optimal drilling sites, maximizing operational efficiency, and minimizing equipment failures through predictive maintenance. Midstream operations also reaping significant benefits from AI, as well as downstream, where artificial intelligence is improving refining and fuel distribution by streamlining operations and reducing waste. But perhaps nowhere is AI's impact more visible than in electricity generation and grid management. There, renewable energy sources like solar and wind are becoming more prevalent. Grid operators relying more on AI to forecast energy demand, balance supply, and prevent outages. A lot's happening, but it's not all good news. Before scaling AI across the sector, it's critical to address associated risks and challenges, including cybersecurity and privacy concerns and threats, as well as miscorrelations caused by inadequate training, insufficient data, which makes the AI well tick, or coding mistakes. And of course, a universal challenge for any industry looking to utilize AI is the shortage of skilled professionals. As of June 2022, only 22,000 AI specialists were available globally across all industries. So how will the energy sector compete? And AI depends on, of course, vast amounts of high quality, real-time data. But the energy sector often grapples with incomplete, outdated, or fragmented data sets. A lot to delve into, and in this insightful webinar, we've got a panel of great experts featuring leaders in energy systems, AI, and data science to explore the challenges organizations face in AI adoption and practical strategies to overcome them. So hopefully some useful takeaways from today on navigating the complexities of AI implementation and unlocking its full potential. As mentioned, a great panel of experts. I'd like to introduce the speakers for this session. First up, Professor Tadhg O'Donovan is Chief Scientist of Heriot-Watt University. Adrian Gonzalez is Program Officer for Innovation and End-Use Sectors at the International Renewable Energy Agency, or IRENA to many of us. Lindsay is Principal Consultant at PA Consulting, and Marina Sigankova is the Director of Global Gas and Coal Research at the London Stock Exchange Group, who will shortly guide us through a presentation to set the scene and the stage for today's very engaging discussion. Marina, over to you.
Thank you, Nawied, and good morning, good afternoon, everyone. It's a great pleasure to be a part of this very interesting and exciting discussion to try to explore the energy implication of AI and what does it mean for shaping commodity research, specifically, where I'm part. But if you just get into the next slide, please. Just let's recognize that what we all experience, that is AI is no longer just a tool for data sciences or tech companies that it was probably considered to be just a few years ago. It becomes a part of everyday life. Majority of us use business tools like Copilot, maybe ChatGPT, Midjourney, even DeepSeek, and even school children are using AI to write school essays, solve the mathematical problem, generate art. And we see that this widespread adoption is accelerating. And naturally with that comes a growing demand for computational power. And probably it's where their energy story around AI begins. We know that there is an ongoing debate about, are we right now in a temporary AI bubble, or is it something long-term structural energy transition which will create a new and large sector for energy demand? We know that to train large language model, to feed them with data, requires a lot of energy. But also one key point in this discussion, that it's inference and not training that will dominate energy use in the future. For example, the Chinese DeepSeek company that was launched 2024, late 2024, claims to use less energy for training their large language model than GPT-4, but still the inference, the usage per query, energy usage per query, requires, say, 0.1 kilowatt per hour. And if we put this into perspective, it's 3 times as much as power needed for a typical search engine query, say in Google. And as we see, AI is becoming more embedded in our daily life, in our daily operation, this energy demands might be significant. Yes, so probably natural questions of how much energy AI use. Just for this reference, I have this chart on the slide, upper right corner. This is from an American company, Hugging Face, that hosts thousands of pre-trained AI models. And they have set up their board to track energy efficiency of different IA kind of usage case. And the chart shows that different tasks require varying amount of energy. For example, generating an image from a text prompt consumes about 5 watt-hour of energy. Generating text uses a bit less of energy. But also to put it into comparison, for example, for us to charge a modern smartphone might need only 22 watt for full charge. So this is practically very interesting thought with the development of this energy needs and AI accelerating where we will be in just a few years. Because literally we haven't heard about, like on a daily life, we haven't used it just maybe 2-3 years ago. And now majority of us use this in our daily life. Also, if you think about the energy infrastructure and decision companies making in regards to AI, we know that, for example, 40% of electricity demand for data centers come from gas to power in the US, and the gas to power consumption is predominantly growing. We had a news as an example of Chevron that they're building specifically gas plants to power data center. Also, developments are also seen in Europe. We know that Europe has built tremendous renewable energy power capacity, and they have been facing with negative price trends, and it attracts data center to these regions, particularly Nordic. I'm based in Norway, and there are news of a Norwegian company numbers, they have been claiming that TikTok's data center has been limiting energy availability for manufacturing ammunition for Ukraine they use. So that's really showing that we are somewhere in transition. And also let's put this into their more global perspective. We know that demand is growing and it's probably going to grow, but how much of the global share of the demand data center might take? So it's still to explore on this part, but for example, the International Energy Agency expect that the global demand of energy demand will grow by 26% by 2030, but most of this will come not from data centers. Still, we are facing rapidly growing electrification in industry, electric car vehicle coming across, needs in air conditioning. So still, we see that the demand from data centers, from AI industry will be growing, but it's probably not might be there overwhelmingly growing from their other electricity needs. But it becomes the sizable share of a relatively new sector for the demand. And next slide. So if I just keep to the part of what we're doing in London Stock Exchange, also as being a part of London Stock Exchange, I'm specifically a part of the gas team where we are using predictive models for commodity trading. And over several years, we have been using machine learning, maybe for over 15 years, even before the AI boom. Like, for example, from my experience as a gas analyst, we have been using machine learning to predict where the LNG cargoes will find a home based on their previous journeys. But still, if we look just past through last 3 years, we started to use large language model from, say, 0 to several. We use it internally, use external trained models, and also probably we also see the shift among new developers where and previously we've been using some regression analysis with the new developers coming, seeing that the deep learning and machine learning becomes the first tool to go and attack the problem. As also a specific example of what we're doing at LSEG, for example, starting from this summer, LSEG publishes, starting from the last summer actually, London Stock Exchange publishes weather forecast from ECMWF, so European Centre of Meteorological Weather Forecast. They're using their artificial intelligence integrated forecasting system, so-called IFS. Over the many years, we have been using traditional weather predictions model, so-called EC forecast, as we use the abbreviation. Those models generated from physical-based numerical weather models, while IFS models is completely data-driven. And on those two small charts which I had is practically a comparison of the model error of the temperature. Those charts are made specifically for France, where we see summer and autumn month, and say what is the predictability of different models. So we see EC operational EC ensembles, those are physical models, and IFS, they are their artificial intelligence models, they purely data-driven, and we see them on the X, and we see them, absolute error versus the days ahead of the prediction. So we clearly see that both of models have pretty good prediction on their first day ahead or second like for tomorrow or the day after tomorrow. But going into, say, day 6 or 8, we already see specifically improvement of IFS models. So still, those physical models has been trained on many years of experience. IFS is relatively new, but so far we conclude it's good to go. And this is a practically good real example in our daily life as analysts and also for our clients. I think with that, I'm happy to head over to you, Nawied. Thank you.
Thank you very much, Marina. Lots of interesting facts and statistics there to set the scene. Before we get going, I'm just going to try and bring in the audience here. We'll move to our first poll question. So you should be able to see this in a second. Just bear with us if you can for a moment. The first question we wanted to get your thoughts on are how can AI most effectively improve efficiency in the energy production process? How can it most effectively improve efficiency in the energy production process? You've got 4 options there: optimizing energy grid management, enhancing predictive maintenance, which we've heard some of there, increasing renewable energy integration, or D, tracking and reducing carbon emissions, all key areas for the energy transition and the future of the industry as well. So if you just give us your thoughts, please, and we'll get the feedback in a few moments, and then you'll see the results on screen. While we do that, I'm just going to kick off the discussion here then. Professor O'Donovan, I'll come to you first. We heard there from Marina some interesting stats and statistics. 26% energy demand, the IEA sees increasing by 2030, and that's not really factoring in entirely the thirst for AI. This is going to require a lot of energy, and we hear a lot about AI for energy and energy for AI. Are we equipped, do you think, as a world to try and deal with the huge thirst and need for data and AI?
Are we equipped? Probably not yet, but certainly on the right path. I mean, it is not new for the energy sector to have to balance complex, phenomena that aren't, immediately evident. So, I'll give you an example that we've been working on for years, of course, and that would be embodied energy or embodied carbon. It's easy in one way to look at the amount of energy that might come from a renewable energy source and even do a techno-economic analysis of that and say it is a net good to us in one way. But if you want to look at it at a whole life cycle, if you want to look at something from the extraction of the raw materials to its manufacture, to everything that is involved in its ultimate energy generation, maintenance, decommissioning, and recycling, then you want to really do that kind of holistic approach to see whether an intervention that you might make in a design might be a positive thing. AI, which will certainly have a huge benefit to the energy sector, we'll have to balance that in as well. We'll have to understand that the energy that we use or the impacts that we have beyond the evident, beyond the obvious, and how they're there. So even having seminars like this, and raising the questions and connecting interdisciplinary is so very important for us to be able to, first of all, surface those challenges and ensure that we make interventions that are going to be positive going forward.
Great, thank you. We've got the results for the first poll. Hopefully this will be able to come up on screen, but some interesting findings. So we had 4 options for you there in terms of the most effective uses of AI, and 40% of you said 4 in 10 thought optimizing energy grid management was going to see most impact. Another 40% thought increasing renewable energy integration, 20%. The remaining 20% thought B, enhancing predictive maintenance, which is already happening across the energy system. And perhaps a bit surprisingly, 0%. None of you thought that tracking and reducing carbon emissions would be where AI would be most effectively used in the energy production process. I'm going to come to you, Liliane, if I can, with that question, because PA Consulting and a lot of your work has looked at decarbonizing the energy sector. AI is doing a lot at the moment to try and drive efficiencies, but is there much more to be done, do you think?
Absolutely. I mean, it's a big question. There's certainly more to be done. I would sort of spin that on its head and say, what have we done to date? The answer is, there's a lot of work being done in academia, a lot of work being done in research facilities, and certainly a lot of investment. But what we see on the ground, and certainly what we're seeing with our clients, is that there is still limited demand for AI applications from an operational standpoint, from energy developers, from the clients that we work with. And that's largely due to some of the systemic challenges that we're seeing across the energy sector to date, which we can get into in a bit more detail later in the discussion. But it does create some barriers to solving some of those tougher decarbonization challenges when it comes to the energy sector. I'm not surprised to see tracking and reducing carbon emissions falling very low on this list. It perhaps mirrors some of the trends that we're seeing to date in shifting priorities when it comes to the energy sector, focusing on energy security, energy independence, given some of the geopolitical factors facing our society to date, and moving away perhaps from some of the decarbonization net zero strategies, or at least putting them on pause for the time being, though that certainly is something we should discuss at greater length, as there's larger implications for the energy sector and society in that regard. I'm not surprised to see optimizing energy grid management and increasing renewable energy integration coming up very high in that list. These are largely sort of integrated or slightly related options, in my opinion, and certainly something that would be pretty powerful if AI could help unlock those challenges going forward. But certainly keen to hear from the other panelists in that regard.
Thank you. Adrian, I'll come to you there because we know that renewable energy, solar and wind, it's seen a huge boost in recent decades in terms of where we were and how we want to try and triple the impact of renewable energy by 2030. Is AI making that more challenging, do you think, this huge thirst for computational power? And are renewables the way to go in terms of trying to power AI's development?
Well, I think AI can be actually a booster for renewable deployment, no? Because if we see a major off-takers for renewable PPAs, we can see companies as Amazon, Microsoft, Google, and precisely they are doing so for feeding their AI-based data center, no? I would say here that the demand that AI-focused data centers will bring to the power system is not problematic whenever there is a proper sourcing. And with a proper sourcing, I'm of course talking about renewable sourcing, and yeah, we need to improve on that field to ensure that the base load that can imply a data center is properly matched with the variable renewable energy sources, no? Also, storage would play a big role here. I would say that also this has big implications for flexibility. The data centers have been traditionally seen as in need for firm power, and there is this discussion about increasing nuclear for feeding them. But actually, in a power system that counts with many with distributed energy sources, you can do an appropriate matching of this demand with variable renewables and with flexible assets, like, for instance, electric vehicle charging, dynamic heating for buildings. So there are many aspects in which the data centers for AI can be sourced with renewables, and the AI applications can help on this.
And just to pick up on that, I mean, we have a world where billions of people are still without constant electricity and power. Do you think that the development of AI may come at a cost in terms of helping connect people who are unconnected at the moment? Because if we're using renewable and other sources to power AI's development, which is happening in a select few countries in terms of development, is that going to come at a cost? Do you think, does it naturally have to come at a cost in terms of other priorities in the energy sector?
We should be very careful on this regard. That's why I was referring before to appropriate matching, and I would say that whenever we are wanting to build new IT infrastructure that requires electricity, it should bring new or additional renewable capacities into the power system, precisely to prevent stealing, let's say, this clean energy from other users, or from access to electricity from the people, particularly in the global south. No? So concepts as additionality, hourly matching should be very important in this system design. Also, it has been said a lot about the water consumption from data centers. It's also a point not to be overlooked. We shouldn't be prioritizing data centers over the population needs. But yeah, I do believe there are being quite some efforts on this regard, and we are going on the right path.
Thank you. Thanks very much. Before we take the discussion forward, I wanted to ask our second poll question. So for the viewers watching, hopefully this will come up shortly. The second question we wanted your thoughts on are: which area within the energy value chain would benefit most from AI adoption? A key question, 4 answers for you, 4 options to choose from. Which area in the energy value chain would benefit most from AI's adoption? Exploration and extraction, energy storage and distribution, energy consumption forecasting, or environmental monitoring and regulation compliance. So delving into the exact areas of the value chain which would have most impact. You can choose an option, please, and we'll bring those up shortly. While we do, Marina, I'm going to take that question to you. What areas within the energy value chain do you think would most benefit from AI?
Yes, yes, I'm back. I think that it's practically considering. I think that it's maybe from my also experience, and I could be biased here, that energy consumption forecasting, and we already see that's really improving. We also particularly, it has been mentioned there, forecast for solar and wind output. Like, it has been proved that those particular forecasting has had a high accuracy. Also, the nature of solar and wind weather forecast has been very volatile. So bringing this AI technology that really help balancing supply and demand, and also as another side of a medal, that also reduce, hopefully, reliance on the fossil fuels, and then improve sustainability. So if you would ask me to vote for one of the 3, so I would vote for C, but I could be biased in that sense. I'm happy to hear from other panelists as well.
Yeah, no, that's the great thing about having a range of experts on, is that hopefully the answers should differ. But some interesting results we've just got in terms of the audience and what they think. So C and D, energy consumption forecasting, you thought was the most important. 0% of the audience thought they agreed with you, and 0 thought environmental monitoring and regulation compliance was the area of the value chain that would benefit most. 20%, 2 in 10 thought exploration and extraction, and energy storage and distribution, surprisingly, 80%. Tadhg, you're nodding your head along to that interesting answer. 8 in 10, energy storage and distribution. Why nodding your head?
Yeah, well, not surprisingly, but I'm not sure which way I would have voted, actually. I think a lot of these are obviously interlinked, and one of the benefits of AI is that it actually brings together data sets and interlinked options like this. So I think there's certainly, we tend to think of energy certainly and how we manage it, how we store it, maybe even how we explore it and generate it. But I think AI is also going to help us design future infrastructure. So what proportion of storage do we need? How does that intersect with future demand? Whether that is because we're better able to predict the renewable energy resource and when we will generate from renewable sources, or whether we're even going to be influencing human behavior, our own need and demand, and be active in that. I mean, there are ways in which this is going to impinge on, economics, on a very individual way, from a domestic setting to large scale organizations. How are we going to incentivize a kind of a collective response to energy decarbonization, which I think is a growing trend? I think all four of these are kind of interlinked. So it is very hard to choose between, but I probably would have gone for B as well.
Great, thank you. And it's interesting, from the first two polls, we've seen the answers related to the climate seem to be not doing as well in terms of, I don't know whether there's some skepticism there, or whether that's changed because of the huge changes in the global sustainability and climate arena in the last 6 months or so with geopolitical changes. But Liliane, let me come to you in terms of what you see in terms of real life uses today of AI. This is something that's not new. Marina touched upon the fact that LSEG were doing this 15 years ago using predictive machine learning. What sort of uses do you see real life cases today in how AI is being used to drive efficiency and move towards a more sustainable future?
Absolutely. Thank you, Naweed. And I mean, the reality is, as with most sectors, most industries, the possibilities are near endless when it comes to AI, especially in the energy sector. There are certainly a lot of barriers that are preventing that or preventing widespread adoption in the energy sector specifically, which I'm sure we'll get into later in the discussion. But a few of the practical applications we've already discussed in the previous poll question in terms of things like predictive maintenance for complex assets, increasingly things like solar fields, wind turbines, transmission distribution lines, etc. These help optimize routine maintenance schedules, predict failures before they occur, leading to lower O&M costs, reduced downtime, a more efficient energy system altogether. These aren't new solutions. They're just becoming increasingly more powerful with AI going forward. Increasingly, we're seeing new software solutions looking to optimize operations and performance analysis for energy assets, helping to maximize energy yields, reduce OPEX, et cetera. The biggest challenge there is commercialization and figuring out sort of the new funding structures for how to deploy these solutions going forward. And then we've spoken a lot already on things like grid optimization programs, improved load forecasting. Again, a bit surprised to see that 0% on the last poll question had energy consumption forecasting as a primary use for AI going forward, or the part of the value chain that would benefit the most. As with what Tadhg said previously, these are all interdependent to some extent. The greatest opportunity for AI going forward in the energy system is creating a more efficient system. Anyone who's worked in the energy sector, anyone who's worked in energy markets will know how incredibly complex they are, both in terms of a development standpoint, development planning, generation, and then balancing supply and demand in real time. I mean, the energy markets are some of the earliest examples of industries that have had to rely on real-time data to figure out how to keep the lights on for thousands and millions of homes across the world in different markets and different systems, navigating different regulatory and legal landscapes and policy landscapes. So, I mean, the massive opportunity for AI here is to really take all of those interdependencies, take all of that real-time data, and create a more efficient, more powerful solution going forward that enables us to use the existing generation that we have to date more effectively, and actually improve some of our sustainability targets going forward. So, there's a lot of talk about how AI will, increase energy demand, increase water consumption. There are also a lot of positives to look forward to in the future about how it can make for a more efficient system going forward.
Absolutely, yeah. And I think we've touched on some of the advantages that it brings as well. Before we move on to our third poll question, just a reminder for the viewers, those of you watching, you can ask a question to any of our experts. Please just click on the Ask a Question tab, and once we get those, hopefully we'll spare some time towards the end of this hour to try and get those answered for you, or as many as we can. Tadhg, I'm going to pick up on what Liliane said there in terms of data being absolutely crucial to this, and the energy sector being at the forefront of a lot of technological advancements in the past. As a scientist, is this as revolutionary, do you think, for the energy sector, but also the world? When we hear so much about AI, it's not new, it's not novel, it's been around since the 1950s, and at Stanford, at least, in the way that we know modern AI. But it's seen a huge boom in investments in recent years, more people, millions, hundreds of millions using apps like ChatGPT now. This is an inflection point, you think, and a scientifically important one for the energy industry and the world.
Absolutely. I think it's the accessibility of AI now and the use of it is going to be obviously much more prevalent. We've been talking about big data for a long time. This is a way of really activating those very disparate data streams. I mean, I'll give you one example of what we're doing as a university. We've campuses from Malaysia, the UAE, and the UK, and we're trying to decarbonize our own 100 gigawatt hours that we use annually. That's a fantastic challenge because we're either trying to cool a building one place or heat it somewhere else, and we're trying to make sure we do it in a very decarbonized way. And our infrastructure is fantastically different as well. Some of it's 200 years old, some of it is cutting edge and just opened yesterday. So we're taking a data-driven approach to this. So we're collecting a fantastic amount of data and observing what is our current operation. And really, we're using AI now through digital twinning going forward to really develop our decarbonized system. And the plan is for us then to demonstrate how, if we can do it, how other people can do it. So but AI has been the key for us, and the data has been the key for us going forward. We didn't want to just look at some big number and say that's 100 gigawatt hours. Let's put in the equivalent generation solar field. We want to do it in a very, very smart way, and in a way in which we optimize. And it's the optimization, I think, actually, where we can look to AI for solutions here, and even figure out what is our figure of merit. Do we want the most efficient system? Do we want the one that is the most economically viable one? Do we want the one with the least emissions over its lifetime? So looking at those metrics puts a lot of challenge in there. But again, data-driven AI, this is going to be the key for us. And we're now speaking a language. Everybody across our organization is now so much more literate and understanding its potential. And that really helps to activate it and to make a real difference.
And I'm going to try to spare some time to talk about data and concerns around regulation as well, which is really, really important for the entire ecosystem of AI, not just in the energy sector, but perhaps particularly in the energy sector, where we're talking about keeping lights on and energy going. But that's a good time, I think, to introduce our third poll question for the audience. Hopefully you should see this on the screen now or momentarily. What do you see as the biggest challenge in integrating AI into the energy sector? The biggest challenge for integration, is it data privacy and security concerns, high initial investment costs around AI, a lack of skilled workforce, which we'll talk about shortly, or regulatory and compliance barriers? So data privacy concerns, the cost of investment, a lack of skilled workforce, or regulatory and compliance barriers. So have a think about that. Please give us your answers. We've had some interesting results so far, and be good to see what people's thoughts are on this. I'll come to you, Adrian, if I may. Obviously, there are challenges in terms of widespread adoption in the energy sector. It's happening. It has been happening for quite some time. But what do you see as the major challenge or barrier for widespread scalability and adoption?
Yeah, I would say the data quality and availability factor is essential. For instance, in the grid operations, the observability of the grid elements, the distributed energy resources I was mentioning before. Back in time, we needed to monitor mainly a set of big power plants, and now we have prosumers everywhere that are able to change from demand to generation because of rooftop PV, because of charging electric vehicles at home and this kind of things. So having reliable data in real time and managing it and having the redundancy that it's required to take operational decisions is essential. No? Also, I would see a bit of a challenge in the responsibility for the decision making process in the control rooms, for instance, from distribution system operator, transmission system operator, or even generation plants. Usually rely on the expertise of the staff in the highly qualified staff in those centers. changing this paradigm into an AI taking a decision that may end in a blackout is a big leapfrog, I would say, and yeah, we have had this discussion some years ago, years ago already, regarding the autonomous driving, and in the power system it applies as well, no? So I would say those are the key challenges.
Thank you. Yeah, and data quality, decision making, absolutely crucial for the development of AI. We've got the results for our third poll. Hopefully, we'll bring this up on screen. I'll tell you what they were. Nobody thought data privacy and security concerns would be the biggest challenge for integrating AI in the energy sector, perhaps. Surprisingly, and we'll delve into data quality shortly, 33% thought the high initial investment costs were preventing AI's adoption and integration. Half of people thought lack of a skilled workforce, and that was the biggest result in that poll. And the remaining 17% thought regulatory and compliance barriers. So C, B, D, and A with 0. Marina, let me come to you in terms of those challenges. We know that automation and machine learning is going to replace some jobs, but the skilled workforce around the world, this competition, if you like, for AI specialists, that's something that's going to be a challenge for the energy sector as well. What do you make of the barriers to AI integration?
Yeah, I think that is also one of the things that practically discussed by was the challenges. I personally don't think that it's one of the most important challenge. But yeah, literally, it's as with any new technology, you need to literally learn it, to adopt it, and it's requires good time and good skills, and also having a good experts to manage and lead this. And we're still learning kind of, and it's probably we're going to see some lag of practically before we as the society able to start adopting it on a high scale. But also again, from my perspective, I would also mention about I would again vote for D specifically, because this is like the regulatory compliance balance. And we can also make the comparison with, for example, the hydrogen industry development, where just a few years ago, that was a new source of energy, the clean source of energy, with a lot of company running into investing and making their strategies. And just a few years after that, we see that company actually withdrawing their plan, reducing their plans. And one of the barriers here is a regulatory and a compliance. Like where there is no clear regulatory framework, there is a risk for companies to start investing. And this could be also one of the serious, in my opinion, barriers to consider.
Thank you. I'm going to pick up on that with Liliane, if I may, please, because the regulation and compliance, the interesting thing about AI and the recent boom we've seen is that many companies and many organizations aren't really waiting for this policy regulatory environment to come along. They want the benefits now and already implementing them. One major international oil company, an executive told me recently that their workforce has gone down from 90,000 globally to about 66,000 in recent years, which is huge savings. But at the same time, they've seen a drive in efficiency and optimization as a result of AI across their value chain. Should we be concerned that the regulation isn't really in place? And this seems to be a difficult thing to try and get regulation and compliance in place in, especially with the spread and speed of which AI is already being used.
Yeah, absolutely. I mean, I would echo what Marina was saying around sort of a ambiguous regulatory environment being a major barrier to AI adoption. I think, interestingly enough, from the list on the previous poll, or the latest poll, one of the notable absences there was sort of wider market factors. I think when it comes to the energy sector, you've got a massive confluence of events in recent years that are impacting the appetite for AI adoption. You're looking at difficult macroeconomic factors around high interest rates, high inflation, global geopolitical factors, war in Ukraine, European energy crisis, the sort of delayed fallout from COVID-19, the impact on energy supply chains. all of which led to this sort of perfect storm in which many energy developers and retail companies are more focused on sort of keeping the lights on and keeping prices low, rather than focusing on innovation and AI adoption. And I think that puts the energy sector a bit behind some other sectors, which is really highlights this regulatory risk. I find it interesting, Marina, that you bring up the development of the hydrogen economy and a lot of hydrogen strategies and sort of this hesitancy to move forward in the absence of regulatory certainty. I think some of the best ways to incentivize or encourage AI adoption in the energy sector would be to use some of these room that we're given from these wider market challenges where energy companies are more focused on other priorities for the time being, to really lobby our governments and our regulatory bodies for creating the environment that is conducive to AI adoption in the energy sector going forward. So I'm talking about things like creating and maintaining a stable investment environment to ensure a clear route to market for large-scale renewables so that they can become the sort of baseload power that can help power these the growing demand for energy use from AI, and then doing things like providing a clear regulatory landscape and policy landscape to help stakeholders effectively navigate not only the energy transition, but also increasingly the AI transition as well. Especially as countries and nations become under increasing pressure to deliver on their decarbonization targets, deliver on their net zero targets, deliver on some of these hydrogen strategies, industrial strategies, et cetera, going forward. And there's additional opportunity, not only on the regulatory side, but on the funding side to do really innovative things like establishing dedicated grants, innovation funds, national technology strategies, et cetera, to support this sort of technology adoption in a critical sector like the energy sector, especially and perhaps most importantly, because of these wider industry challenges that will act as a barrier to adoption, because this will ultimately yield benefits for the wider energy system and to end consumers in the long run.
Brilliant, thanks. And it's a really important point you make, I think, about the geopolitical and geoeconomic environment, because few industries, I think, around the world, if you take oil and gas and energy, are as receptive and change as much when global oil prices or the price of energy is up or down. So it's something that definitely does impact investment. And you'd think that AI would be among those sorts of areas that would be cut back or increased once the geopolitical environment moves one way or the other. Tadhg, let me come to you on data, because data really is, I mean, it's the bedrock of AI. We keep hearing that what goes in is what comes out, and this thirst for data is going to only amplify. We're handing a lot of it over at the moment. Do we really appreciate just how risky and dangerous that is? And do you think there needs to be more transparency in AI's development, particularly given that we're all using it on such a scale around the world?
Yeah, absolutely. And this very much continues on from what Liliane and Marina were saying too. The regulatory framework will want to be very strong on this side as well. Partly to protect ourselves from not making bad decisions from whatever AI is going to put in front of us. You know, the idea of explainable AI and understanding the source of it, so that we have our own, standards and safeguards, I would say, is actually at the forefront of it. Beyond that, I don't know, it could be on my own here. I have less concern about the individual's privacy from this. It depends on your perspective here and what you think the data has been used for. But we're talking about massive data sets here. We're looking for global trends. You're looking at it can be used for nefarious means. Of course it can, for as long as it's accessed at all. But it isn't AI that's doing that. It is the fact that the data is readily available and therefore could be explored or interrogated to a way that we might not like. It is incredibly powerful. It is driven by huge, large data sets that are transient, that are moving and changing all the time, and so that is the intent of the AI. But that open access to data is technically it's a separate issue. I'd be actually quite interested to know what my colleagues think of this.
Yeah, it's an interesting one, and I guess we're still at a stage, at least, or as far as we're publicly aware of the human element and human touch being in the driving seat when it comes to AI's development. But what happens long term in terms of artificial generative intelligence and superhuman AI, as we're hearing about that's yet to come. It'll be interesting to see how that impacts things. But again, seeing a recent example at an oil rig where cameras were being used to zoom in and identify where the workers were and also whether they were wearing the right PPE equipment, health and safety concerns, all of that just from the one camera and a bit of AI. So it is a privacy concern, and it is something I think that companies ought to be thinking about, as well as individuals and workers as well. Let's go to our final poll question. We've got about 10 minutes left before we end this webinar, and lots to get through still. The fourth and final question for the audience, hopefully you'll see this on your screens now, is how ready is the energy industry to implement AI solutions on a large scale? We've been discussing about some of the challenges and some of the advantages of using AI already, but how ready do you think the energy industry is? Very ready, moderately ready, or not ready yet? So please give us your answers, and I'll come to you, Adrian. What do you think in terms of AI's adoption on a larger scale? We've heard about the renewable energy sector, but there's a lot happening in other parts of the energy mix. If you think of nuclear, which you touched upon earlier, and small modular reactors being built, is there a lot more to come, do you think, in terms of implementing AI solutions on a grander scale that we haven't really fully grasped yet?
I would say that material science is a field going upstream that where renewables can greatly benefit from the use of AI. So, for instance, in developing new PV modules with new materials, new chemicals, like advanced perovskites, but also in other fields as storage, battery storage, also hydrogen, composite materials that can emerge to solve engineering problems that we are seeing in the last decade for going above and beyond in the renewable adoption. So I would say that this is a field to be explored. Maybe the effort should go there rather than small modular reactors. Back to the original aspects mentioned in the beginning about the energy consumption from data centers. Yeah, some time ago, small modular reactors were a trending topic, no, because they were seen as appropriate for feeding data centers, but now we're seeing data center clusters that exceed the gigawatt of power. So small modular reactors may not make sense anymore for this purpose, no? So yeah, I would say that thinking in the longer horizon, investing in renewables is a wiser approach. And I remember in one of the polls before, we were talking about exploration and extraction. Well, this is indeed something where AI can have a role for oil and gas. But I would like to stress here that there is also a huge potential for geothermal and for ocean energies that are often overlooked. And they are overlooked because in the past we were having issues to identify geographical areas with high potential for these energies. And AI can play a very big role here. So if we use these advanced technologies for these renewables, they may become really a game changer in the coming decade.
Thank you. And we've got the results. Thanks for that, Adrian. We've got the results of the last poll question. So we asked, how ready is the energy industry for wide-scale adoption? Very ready. Nobody thought that the industry was very ready, and even split to finish with in terms of moderately ready and not ready yet. 50-50 for those last two. So some skepticism about how quickly things will move. Tadhg, let me come to you briefly, if I may. There are certain parts of the world that may have a competitive advantage in terms of developing AI and its power in the energy sector. The Gulf countries I'm thinking of in particular, they're looking at not just producing AI in the case of the UAE, but Saudi Arabia introducing it in schools as part of their curriculum, as many other countries have done. And of course, they have access to cheaper energy, as well as the industrial capacity when it comes to the energy sector. Do you think it's natural that Gulf states will have a competitive advantage when it comes to AI in the energy world?
I do. Having lived in the UAE for the past 8 years now, I think when I came here first, they had a ministry for AI, which might have been one of my first introductions to AI, to understand what is this all about. And they have been, investing in it and looking to the future of AI for many years. We as a university then that has a base around the world, it's interesting to see how we've evolved, or how the sector, the educational sector, has had to evolve in the past few years because of AI. Not just in how we operate and what everybody assumes is plagiarism in exams or misuse of AI, but actually how do we produce the graduates of the future that are going to be much more AI literate. And a few years ago, I suppose we had programs, computer science programs and data science programs at postgraduate level and undergraduate level, but now it's about integrating it into every degree program that we have, so that as your students graduate, they're much more literate and they're much more aware of the potential, and they're able to speak more fluently with, in an interdisciplinary context about how it can be used. That's driven because of as I said, we're a global institution. I think it certainly has been driven by our location and our operation here in the UAE and the Gulf countries that have definitely been very forward on this and investing largely in what they see as a growing and huge potential industry.
Yeah, but one that's strategically important for the economy and world in the future, I think, which is driving a lot of their decision making. I'm going to ask for the three panelists to just give us in 6 seconds, please, some closing statements as we wrap up. Liliane, I'll start with you. Some thoughts on today's session and the importance of this discussion, please, in 60 seconds.
Thank you very much. I'd just like to spend this time responding a bit to some of the poll questions that have come through. It's not surprising that in the last poll question, 0% said that the industry is very ready. I'd like to modify this slightly by saying that parts of the industry are ready. We're already seeing AI being deployed across different elements of the energy sector. Here at PA, we've notably helped Sellafield, a major nuclear site in the UK, actually develop AI solutions, particularly to aid with regulatory compliance, which is why it's interesting that no one said AI will be most valuable in regulatory compliance. But there's ways to integrate AI in new and innovative ways across different parts of the energy sector and the energy value chain. And the major opportunity here is to reevaluate our approach to energy systems, energy markets, energy generation, et cetera, and truly use AI's power to grapple with large data sets, to integrate a number of different interdependencies, to really create some powerful predictive analytics and insights to create more efficient systems going forward. And I think that, not just looking at where it will be most helpful in parts of the value chain that as it currently exists, but actually reevaluating the value chain altogether will be sort of what the future state of the energy sector will look like in an AI and empowered world. I'll pause there and thank you very much for the session today.
Thank you. Marina, your final thoughts, please, in 60 seconds or less.
Yes. No, I think that it was very interesting discussion and just reveals how much of uncertainty and also knowledge gap we also have, like practically having those poll answers where we be in a disagree and agree on some parts of it. But also it reveals how kind of game changer AI is becoming in energy sector. Is also the implications brings, like the efficiency we discussed, different tools that predictive maintenance, renewable energy forecasting, improving the forecasting of demand, but at the same time it has gain in efficiency, but it adds for energy demand at the same time where we can balance. I think it's practically adds to complexity, as Liliane also already says. The energy system is very complex. It has been pretty complex, and it's adds another layers of complexity, which means, like, yes, we need to follow this more than probably we've done. It's just practically it reveals a lot of potential and also uncertainty.
Yeah. Thank you. And yeah, I think it's discussions like this really important at this time to delve into these game-changing technologies. Adrian, a final word from you, please.
Yes, thank you. I do believe that AI has a major role to play in the coming years for renewables, starting from better forecasting, for higher integration of variable renewables, but also, as mentioned, for material science and operational automation in the power system. We should keep in mind that it's a tool, and as any other tool can be used for good or for bad. The wiser use here is renewables and not fossil fuels.
Perfect. Thank you. A good note to end on in terms of the opportunities and potential risks as well for AI, which should be something that we should all be thinking about. But thank you so much for attending this webinar. Fascinating discussion. A lot we covered in that hour. The webinar series supported by the Al-Attiyah Foundation in partnership with the London Stock Exchange Group Data and Analytics team. And we look forward to welcoming you to future webinars. Before we go, if I can please just encourage you to fill out the post-event survey, which will be really useful for the team and improving things for the future. That's shown on the screen now. Hopefully you should see that QR code, or it can be filled on the same event page as well that you received communications. But thank you once again for attending this webinar, and thank you to all of our panelists for a fascinating discussion. Goodbye.